Charamadi. In this module, we are going to carry out removing and fitting of new pilot bearing, removing and fitting of ring gear in flywheel, realigning a clutch plate, checking condition of flywheel and pressure plate surface for reconditioning. At the end of this exercise, you shall be able to remove and refit the pilot bearing, remove and refit the flywheel ring gear, realigning the clutch plate, checking the condition of the flywheel and pressure plate. Now let us take a look at the equipment, materials and tools required.
Tools or instruments. Trainees toolkit 1 number. Straight edge 1 number. Box spanner 1 set. Special tool, bearing puller 1 number. Torque wrench 1 number. Equipment or machineries. Heavy vehicle 1 number. Materials. Cotton waste. Cleaning tool. Soap oil. Pilot bearing. Before we learn to inspect the pilot bearing, let us see what is the role of a pilot bearing and how to identify when it is faulty. When the clutch is disengaged, the transmission's input shaft and the engine's crankshaft are rotating at different speeds. The pilot bearing allows for this difference. This is why a faulty pilot bearing makes its most noise when the clutch pedal is completely depressed and the clutch itself is completely disengaged. It's located in the center of the crankshaft flange or flywheel. Pilot bearings sit between the engine and the clutch and allow for the speed difference between transmission shaft and crankshaft. Early signs of the pilot failing may be noise whenever the clutch is disengaged. The driver may also notice that the transmission is difficult to shift between gears or hard to put into reverse or first gear when stopped. A worn or damaged pilot bearing will make a whining or grinding noise. It will be very loud if the bearing is completely damaged. It occurs whenever the crankshaft and input shaft are rotating at different speeds. Now let us move on to the procedure. Task 1. Removing, cleaning, inspecting and refitting pilot bearing. Start by removing the gearbox assembly, followed by the removal of the clutch assembly. Proceed to loosen the mountings of the flywheel. Next, remove the bolts securing the flywheel assembly and take out the flywheel assembly. Thoroughly clean the flywheel mounting flange and the pilot bearing located at the rear end of the crankshaft. Attach a special tool designed for pilot bearing removal and gradually pull out the pilot bearing using a bearing pulley, placing it onto a tray. Subsequently, clean the bearing using kerosene and then using air pressure to eliminate any microscopic particles. Conduct a thorough inspection of the bearing for any signs of damage. Check the bearing noise. If damage is detected, replace the pilot bearing with a new component. Apply grease to the bearing fixing spot and position the bearing onto the rear end of the crankshaft. Using a brass drift and hammer to securely fix the bearing, ensuring it is properly fitted. Verify the bearing play with the help of clutch shaft. Ensure there is no excessive play or noise in the bearing. Following the bearing inspection, mount the flywheel and clutch assembly, and use the clutch shaft for aligning the clutch plate. Fix the thrust bearing and reattach the gearbox assembly. Finally, connect the clutch pedal linkages and transmission linkages to complete the process. Task 2. Removing the flywheel ring gear. Begin by loosening the mountings of the flywheel. Then, remove the flywheel mounting bolts. Following the necessary safety precautions, carefully take out the flywheel and place it on a workbench for further examination. Clean the entire flywheel assembly and inspect the fitting of the flywheel ring. Remove the flywheel ring using a brass drift and hammer. In cases where the ring is stubborn and unable to be removed, heat the ring and remove it. Thoroughly clean any dust and rust accumulated on the flywheel. For refitting the flywheel ring gear, select a new flywheel ring and before placing it, use a propane torch to heat the flywheel ring evenly around 300 degrees. Once appropriately heated, position the flywheel ring on the flywheel and make use of a hammer and brass drift to clamp it securely in place. Task 3. Relining clutch plate. Begin by carefully examining both the clutch plate and lining. To remove the old rivets, use either drilling or a center punch with a hammer. After successfully removing the old linings, cleanse the clutch hub and cushion springs. Conduct a thorough inspection of the clutch hub flange, torsion spring, and cushion spring for any signs of damage, cracks, or noise. If any such issues are identified, repair or replace the damaged components. Select the appropriate size of clutch lining and rivets for the replacement. Before relining, ensure the clutch linings and hub unit are thoroughly cleaned. Align the rivet holes on the clutch spring with the clutch lining and secure the linings to the clutch plate using hand-wise or C-clamps. Adjust the clamps as close as possible to the rivet holes. Under the guidance of an instructor, use a foot-operated riveting machine to rivet the linings to the clutch plate in sequence. After riveting, check the tightness of the lining rivets to ensure a secure attachment. Confirm that the clutch linings are properly riveted before putting the assembly back into use. Task 4. Inspecting pressure plate. Commence the pressure plate inspection by cleaning its surface thoroughly. Further, visually examine the friction face of the pressure plate to identify any signs of wear or damage. Using a straight edge and feeler gauge, assess the flatness of the friction face. If the flatness is not within the specified limit, it is recommended to resurface the pressure plate. However, exercise caution not to grind it below the minimum specified thickness during the resurfacing process. Task 5. Inspecting flywheel. Start by visually examining the flywheel surface for any cracks, signs of burning, or scoring. Evaluate the warpage of the flywheel friction surface using a straightedge and feeler gauge. If the warpage exceeds the minimum limit specified by the manufacturer, it is advisable to have the flywheel reground. Additionally, assess the ring gear for any wear or damage, and confirm the serviceability of the pilot bearing. Mount the flywheel onto the crankshaft and keep it on the inspection table. Record the phase runout of the flywheel using a dial indicator. If the phase runout of the flywheel surpasses the minimum limit specified by the manufacturer, consider having the flywheel reground. During the grinding process, ensure that the thickness of the flywheel remains within the limit specified by the manufacturer to maintain its structural integrity.
We have come to the end of the exercise. Let us have a recap on what we have learned in this module. Remove and refit the pilot bearing. Remove and refit the flywheel ring gear. Relining the clutch plate. Checking the condition of the flywheel and pressure plate. Thus, we have learned to carry out removing and fitting of new pilot bearing, removing and fitting a ring gear in flywheel, relining a clutch plate, checking condition of flywheel and pressure plate surface for reconditioning. Do this exercise with the help of your instructor. Thank you. Perform assembling of pressure plate, adjusting the fingers, checking run out of flywheel and aligning clutch assembly with flywheel. Hello, my name is Charumati. In this module, we are going to assemble the pressure plate, adjusting the fingers, would be checking the run out of the flywheel and align the clutch assembly with the flywheel. At the end of this exercise, you shall be able to assemble the pressure plate assembly, adjust the pressure plate fingers height, check the run out of the flywheel, aligning the clutch assembly with flywheel, assemble the pressure plate. First, let us see the equipment, materials and tools required for this task.
Tools or instruments required. Trainees toolkit 1 number. Torque wrench 1 number. Depth gauge 1 number. Box spanner 1 number. Clutch aligner 1 number. Dial indicator 1 number. Surface plate 1 number. Equipment or machineries required. Heavy vehicle 1 number. Materials needed. Cotton waste. Soap oil. Clutch finger. Roller and strut. Release lever spring. Bolt and pin. Pressure spring. Let's first learn what is pressure plate. The pressure plate is the most critical part to the whole clutch assembly. The pressure plate applies a clamping force, pressure, which holds the driven friction disc between it and the flywheel. The pressure plate is fixed to the flywheel with bolts and they rotate together. The pressure plate contains a diaphragm or springs that apply the pressure on the main casting or driving surface. In order to release or disengage drive, the diaphragm or clutch levers are actuated, which allows the main casting to lift off the driven disc. Now, let us see how to assemble the pressure plate. To start, first place the pressure plate on a surface. Then, place the pressure spring on the pressure plate. Now, attach the release lever with strut, eye bolt, and pin. Finally, secure the release lever spring in its designated spot. Make sure everything is aligned by matching the marks on both the clutch cover and pressure plate. Finally, put the pressure plate onto the clutch jig. Compress the pressure spring with the clutch jig. Mount the eye bolt nuts and tighten them evenly. After that, release the load from the springs and gently take off the pressure plate assembly from the clutch jig. Visually check the height of the finger. Check and adjust the finger height with the help of depth gauge and spanner. You need to ensure that the finger height is as specified by the manufacturer. Next, let us learn what flywheel runout is. Flywheel runout is measured by the total distance the crankshaft will move front to back when installed in the engine. The crankshaft journals are machined to accept the appropriate bearings that hold the crank in the engine assembly. A predetermined amount of clearance will allow for the crankshaft to turn easily. An excessive amount of clearance will allow the crankshaft to move too much. Task 2. Checking run out of flywheel. Start checking the flywheel by putting it onto the crankshaft flange. Make sure it's held in place by tightening the mounting bolts to the limit recommended by the manufacturer. This ensures the flywheel is securely attached to the crankshaft, providing a stable base for the next steps. After securing the flywheel, clean the frictional surface of the flywheel. Set up the dial indicator on the flywheel as shown. Place the dial indicator to match the mark, making sure it works accurately. While doing this, rotate the flywheel to thoroughly check it. At the same time, carefully look at the friction surface and see if there is any movement in the flywheel. It's important to make sure that the observed movement is within the allowed limit, showing that the flywheel is in good condition. Following these steps helps thoroughly check the flywheel's condition and decide if any maintenance or adjustments are needed to make it work better. The main purpose of the clutch system is to isolate the movement of the engine from the wheels while driving a changing gears. With proper clutch assembly in place, we can achieve the correct transmission of the engine power from the gearbox, which is then transferred to the vehicle's wheels. Procedure. Task 3. Aligning clutch assembly with flywheel. Start putting things together by placing the clutch plate on the flywheel, keeping the clutch plate's hub opposite to the flywheel. After that, put the pressure plate assembly on the flywheel and the mounting holes with pressure plate. This careful and organized alignment ensures the clutch parts are installed correctly on the flywheel. Move forward by screwing in the pressure plate onto the flywheel, using your hands to tighten them a bit, and start the assembly. After this initial step, use the clutch aligner tool to make sure the clutch plate is perfectly aligned in the system. Once the clutch plate is in the right position, tighten the screws of the pressure plate using the recommended force specified by the manufacturer. Doing this makes sure the parts are firmly attached. Conclude the assembly process by removing the clutch aligner. This systematic and step-by-step approach guarantees the secure installation and accurate alignment of the clutch components onto the flywheel. The careful execution of each stage contributes to the overall functionality and longevity of the clutch system within the vehicle.
We have come to the end of the exercise. Let us have a recap on what we have learned in this module. We have learned to assemble the pressure plate assembly, adjust the pressure plate finger's height, check the runout of the flywheel, aligning the clutch assembly with flywheel, assemble the pressure plate. We have learned to perform assembling of pressure plate, adjusting the fingers, checking runout of flywheel, and aligning clutch assembly with flywheel. Do this exercise with the help of your instructor. Thank you.
Hello and welcome to the session on performing brake service procedure. By the end of this exercise, you will be able to inspect the brake shoe and lining for signs of wear and drill out the old rivets for removal. To replace the old lining with a new one and secure it in place. Identify the parking brake lever, ratchet and cable components. Evaluate the importance of proper garment installation and application of specified grease.
Tools and equipments required: trainee's toolkit, feeler gauge, C-clamp, flat reed drift, oil can, disc puller, one vehicle, one set jack and horse stand, and one bench vise. Materials required: cleaning solvent, brake liner, cotton waste, grease, oil seal, cotter pin, kerosene, sandpaper, wheel chalk, brake fluid, brake pad, rivets and brake shoe retainer. Let's initiate the session by taking steps to remove the existing lining and install a new one. First, we begin by thoroughly checking both the brake shoe and lining for any signs of wear. This helps us catch and address any potential issues before moving forward. The next step is to get rid of old rivets, and it's crucial to file away any burrs or high spot to make sure we have a clean surface to work with. After that, we remove the old lining, and to replace it, choose a new brake lining that matches the size of the drum, making sure it fits perfectly. Now, selecting the right rivets is important. So, for a secure attachment, we should use a rivet which is matching to the hole size. Clean the contact surface of both the shoe and lining to promote effective bonding. Align the rivet holes on the brake lining with precision and secure the linings to the brake shoe using C-clamp in a vise. Adjust the clamps close to the rivet holes for stability during the riveting process. Now start riveting from the center towards the ends, adhering to manufacturer's specifications. Driving the rivets squarely into the holes with a flat head drift ensures a secure and robust connection, minimizing the risk of misalignment or instability in the brake lining assembly. After riveting, carefully check the gap between the brake lining and shoe using a feeler gauge. This step is crucial for ensuring the right spacing between the rivets, which is essential for the brake system to work correctly and safely. Finish the procedure by carefully filling both ends of the brake lining. This ensures smooth, curved surfaces, contributing to the braking system's overall functionality and durability. This meticulous procedure guarantees a reliable and efficient brake lining replacement. Next, let us look at the comprehensive guide to parking brake maintenance and adjustment. The parking brake, also known as the emergency brake, plays a pivotal role in keeping the vehicle stationary, reducing stress on the transmission system and contributing to overall longevity. For adjusting the parking brake cable, first we must dismantle the braking box. Start by removing the console box. This step is essential as it allows for further disassembly and adjustment of the parking brake system. Next, we proceed to loosen the adjusting nut and detach the parking brake cable, a vital link in the braking mechanism. Proceed by detaching the parking brake switch assembly and removing the parking brake lever assembly. These components play a vital role in the functionality of the parking brake system. As you remove each part, ensure you keep track of the hardware to facilitate smooth reassembly later. The next step is to remove the wheel and brake drum to access the brake shoes. Carefully follow the outlined procedure for removing the brake shoes, paying attention to details to avoid damage. Detach the parking brake cable from the brake shoe and remove the cable retaining in the rear of the backing plate. Additional steps involve removing the rear seat cushion assembly and rolling up the carpet. This step is necessary for accessing the parking brake cable and adjusting its various parts. Moving forward, the disassembly continues by loosening the parking brake cable clamp and removing the entire parking brake cable assembly. This step is pivotal for gaining access to the inner working of the parking brake system. Now, inspect the parking brake lever ratchet for wear and check the parking brake cable for any signs of frying or damage. It is crucial to ensure that each component is in optimal condition for the parking brake system to function effectively. Check for left and right identification marks on the parking brake cables and install them accordingly. This step is often overlooked, but It is essential for maintaining the correct operation of the parking brake system. Moving on to the adjustment phase. Shift the adjust lever all the way back when installing the shoe-to-shoe spring. Install the grommets as directed. Apply a coating of specified grease to the sliding parts of the ratchet plate and ratchet paw. After installing the cable adjuster, proceed to adjust the parking brake lever stroke. This final adjustment is critical for ensuring the proper functioning of the parking brake system.
Let us recap this topic. In this topic, you have learned that selecting the right rivets is important for a secure attachment. We should use a rivet that matches the hole size. After riveting, carefully check the gap between the brake lining and the shoe using a feeler gauge. Check for left and right indication marks on the parking brake cables and install them accordingly. Hope you have clear understanding of this. Do this exercise with the help of your instructor. Thank you. Hello and welcome to this session on performing brake service procedure. By the end of this exercise, you will be able to understand the importance of wheel rotation and securing the eccentric position for effective brake adjustment. Identify essential precautions for brake testing, including checking engine serviceability, tire conditions, and wheel components. Conduct a thorough examination of the vehicle, including tire wear, pressure, wheel nuts tightness, and lights and switches functionality. Use a panel board to simulate engine conditions.
Tools and equipments required. Trainee's toolkit, jack, wooden block, vehicle. Materials required: cotton waste, soap oil, bleeding nipple, slack adjuster, grease. Let's start the session by tracking trouble in a brake system involves a systematic approach to ensure optimal performance. Begin by jacking up the wheels to clear the floor, allowing easy access to the brake components. Once elevated, loosen the eccentric cam of the leading brake shoe and, with the help of a wrench, turn it towards the front until the brake shoe contacts the drum. After the brake shoe and drum contact, rotate the wheel to ensure free movement. Then hold the eccentric in position and tighten the lock nut. Repeat this process for the reverse shoe, turning the eccentric towards the back of the vehicle. This adjustment must be performed on all four wheels for comprehensive brake turning. After adjustment, carefully remove the jack from each wheel. Once adjustments are complete, remove the jack and check brake pedal play to guarantee a proper response. Now, as a next step, start the vehicle and inspect the brake boot for balancing across all four wheels. Ensure equal brake effectiveness in each wheel to guarantee a balanced braking system. If the vehicle is equipped with hydraulic brakes, it is essential to bleed the brake system before adjusting. Additionally, ensure that the fluid level in the master cylinder is adequately maintained. Our next topic is to ensure the optimal performance and safety of a vehicle's brake system. Begin by examining the engine's serviceability and assessing its overall functionality and condition. Moving on, scrutinize the condition of all tires, emphasize equal wear across them, Verify that the tire pressure adheres to specific limits, promoting proper traction and longevity. Now, shift your focus to the wheel assembly and examine wheel nuts for tightness. Assessing the integrity of these crucial components. Moving on, inspect wheel bearings to guarantee their smooth operation. Assess steering linkages for play within acceptable limits, ensuring responsive and controlled handling. Evaluate the suspension system serviceability to maintain stability and comfort during operation. Thoroughly check the vehicle's body fitting for security and integrity. Direct attention to the brake system by examining the brake pedal for free play and making necessary adjustments. Check the master cylinder for fluid level and potential leakages from the fluid line, addressing any issues promptly. Ensure a clean interface between the brake shoe and drum by verifying the absence of oil or grease. Next is for air brake systems. Systematically examine for any air leaks and confirm proper lubrication of brake linkages. Conduct a meticulous review of lights and switches within the vehicle, addressing any malfunctions. Access the functionality of the vacuum booster in vacuum assisted brakes, a critical component for enhanced braking power. It is important to use an engine panel board for simulation purpose. And the next step is to release the handbrake and check the vehicle's performance in motion. Further, assess the vehicle's braking effectiveness by applying the foot brake at 10 km/h, ensuring a prompt response. Continue the same procedure to examine for high-speed scenarios, ensuring uniform braking effects across all wheels. Certify that the vehicle's brakes are roadworthy before issuing a brake fitness certificate for the vehicle.
Let's recap this topic. In this topic, you have learned that after the brake shoe and drum contact, rotate the wheel to ensure free movement that holds the eccentric in position and tighten the lock nut. Shift your focus on the wheel assembly, examine wheel nuts for tightness, assessing the integrity of these crucial components. Check the master cylinder for fluid level and potential leakages from the fluid line, addressing any issues promptly. Hope you have clear understanding of this. Do this exercise with help of your instructor. Thank you. Hello and welcome to this session on practice maintenance of ABS system. By the end of this exercise, you will be able to explain how to handle the regular brake maintenance, describe how to manage ABS maintenance.
Tools and equipments required. Trainees toolkit, steel rule, vehicle, materials required, brake fluid, flexible tube, bunion waste. Let's begin this session by explaining how to handle regular brake maintenance. Begin by inspecting the brake fluid level in both sections of the master cylinder. Adequate brake fluid is crucial for proper brake system function. If the level is low, top it up to the manufacturer specified level. The next step is to examine the brake pedal for proper free play, ensuring it moves smoothly without excessive play. Adjust the brake pedal free play to meet the manufacturer's specified level, optimizing pedal responsiveness. Then thoroughly check all the brake lines and fittings for any signs of leaks. Any leakage could compromise the braking system's efficiency and must be promptly addressed. Now inspect all the brake tubing for rust, corrosion, leaks and damage. Corroded or damaged brake tubing can jeopardize the integrity of the braking system, making regular inspections crucial for identifying and rectifying issues. Then you should ensure that each wheel rotates freely. Difficulty in wheel rotation may indicate improper brake release, necessitating attention to prevent uneven brake wear and potential performance issues. Once all the procedures are taken care of, conduct a road test to evaluate the efficiency of the braking system. This provides valuable insight into the brake's functionality under real-world conditions. During the road test, ensure the brake pedal offers proper feeling and responsiveness. Additionally, check the hand lever of the handbrake for proper spring action, confirming its ability to engage and disengage effectively. Let's begin this topic by understanding what is ABS, and we'll also have a look at the maintenance of ABS. ABS, Anti-Lock Braking System. Maintenance is crucial for ensuring the proper functionality of this integral safety feature in vehicles. Begin by checking the ABS wiring harness for any damage or insulation. Damaged wiring can compromise the system's electrical connections and communication, potentially affecting the ABS responsiveness during braking. Inspecting all lines and fittings for leaks is essential to prevent hydraulic fluid loss, ensuring the ABS system maintains optimal hydraulic pressure for effective braking. After starting the engine, observe the ABS working light. The light should initially remain illuminated for approximately 5 seconds before turning off, indicating normal ABS system self-check. If the ABS warning light remains continuously lit behind 5 seconds, it indicates a potential problem and requires attention. To identify and rectify faults, a scan tool is employed. This diagnostic tool can pinpoint specific ABS problems, allowing technicians to follow instructions provided in the service manual for effective troubleshooting and resolution. The next step in this topic is to check the tooth rings. Tooth rings are integral components in systems like ABS. Inspect the tooth rings on the wheel for any damage. If damage is identified, promptly replace the affected tooth ring. This proactive approach ensures the proper functioning of critical systems like ABS, preventing potential issues and maintaining the vehicle's safety and performance standards. Let's begin this session with ABS bleeding. The process begins by turning the ignition key on and repeatedly pumping the brake pedal until the hydraulic pump motor engages. This step pressurizes the hydraulic system, preparing it for bleeding. Subsequently, one waits for the hydraulic pump motor to shut off, indicating that the system is pressurized and ready for bleeding. With the ignition switched on, an assistant is then instructed to apply the brake pedal. The purpose is to create pressure within the hydraulic system, facilitating the removal of any trapped air. To bleed air from the system, a hose and glass container are used, with the bleeder screw being loosened and tightened as needed. This step expels air from the hydraulic system, ensuring optimal brake performance. Finally, brake fluid is added to the master cylinder reservoir as required. Completing the ABS bleeding process, adequate brake fluid levels are vital for the proper functioning of ABS, maintaining hydraulic pressure within the system.
Let's recap this topic. In this topic, you have learned that after starting the engine, observe the ABS working light. The light should initially remain illuminated for approximately 5 seconds before turning off. Ensure that each wheel rotates freely. Difficulty in wheel rotation may indicate improper brake release. Hope you have clear understanding of this. Do this exercise with the help of your instructor. Thank you. Hello and welcome to this session on Perform Troubleshooting Practice with Heavy Vehicle for Engine Not Starting. Let's start with this topic. On completion of this session, you will be able to identify the significance of battery terminals, starter switch and battery in the starting process. Understand the importance of checking fuel leakage, air cleaner, tappet clearance and cylinder head tightness.
Tools and materials required: trainee's toolkit, multimeter, a car in running condition, gloves, bunion cloth as required, emery sheet as required, cleaning solvent as required. Let us get familiar with the electrical and mechanical issues of the vehicle's engine. Let's get started then. Firstly, examine the battery terminals for looseness or corrosion. Loose terminals can potentially cause engine startup problems. If battery dies, you can charge it or replace it with a new battery. If the terminals are loose or unclean, clean them and tighten them. Examine the starting switch. If the switch is faulty, the starter motor will not receive electricity and will not start the engine when the ignition switch is turned on. The next step is to examine the battery. A faulty or dead battery could be the source of the problem. If the battery is dead, charge it up or replace it. Once the battery is changed or replaced, check the starter motor. If there are any issues with the starter motor, replace it. These are the electrical causes. Now let's have a look at the mechanical causes. Begin by inspecting the fuel tank to ensure an adequate fuel level. If the tank is found to be lacking fuel, proceed to fill it before attempting to start the vehicle. Examine the fuel lines for blockages. If the fuel pipes are clogged, remove the block and replace it. Examine the petrol tank's vent hole. Remove any clogs from the vent hole. Now check the fuel filter. Check for clogs and clean the filter. If it must be replaced, do so. Examine the silencer and exhaust manifold. If the exhaust manifold and silencer are clogged, clean them. Getting the ignition timing just right is important for a good engine burn. This timing depends on when the valves and ignition works. If things are not timed correctly, you may need to adjust the injection timing. If injector is not working properly, perform an overhaul on the injector. Examine the fuel injection pump. If you discover that the injection pump is faulty, replace it, adjust it and reinstall it. Now all you must do is check the engine compression and replace the faulty compressor. Let's get familiar with how to check high fuel consumption. Let's get started then. To start, it is crucial to inspect for fuel leakage and promptly address any issues found. Checking the air cleaner and cleaning the air filter if clogged helps maintaining proper air intake. Similarly, monitoring the fuel filter for clogs and replacing or cleaning it as necessary ensures a consistent fuel supply. The next step is to check the tappet clearance. Tappet clearance should be checked and adjusted to specification to guarantee proper engine functioning. The cylinder head's tightness is vital due to thermal expansion and contraction. Any flaws can lead to cracks, emphasizing the need to tighten it according to specifications. Next, check the silencer and the exhaust manifold. Loose components like the silencer and exhaust manifold should be tightened to prevent issues.
Injection timing plays a critical role, and if incorrect, it should be reset for optimal performance.
Defective injectors should be overhauled or replaced, while the fuel injection pump requires regular checks for defects, with the subsequent overhaul and recalibration if needed. It is essential to keep track of the engine's compression pressure to ensure it aligns with the recommended levels. If the fuel pressure falls below the specified range, it becomes imperative to undertake a compression overhaul. The next troubleshooting we are going to perform is engine overheating. Always remember that proper maintenance of a vehicle's cooling system is essential for preventing overheating and ensuring efficient engine operation. Start by checking the water level in the radiator and fill it to the recommended level to prevent overflow. Examine external leakages and inspect radiator hose for cracks, replacing any damaged hose to maintain the integrity of the system. Ensure the fan belt tension is optimal, avoiding it being too loose, and adjust as needed to prevent slippage. Now you have to verify the functionality of the thermostat valve, which regulates coolant flow to the radiator once the temperature reaches 90 degrees Celsius. Tighten any loose cylinder head components and check tappet clearance to maintain proper engine function. The injection timing plays a crucial role, and if found incorrect, it should be reset for optimal performance. Inspect the radiator pressure cap for defects. Replace it if necessary. Now, check for internal and external clogs in the radiator cores, cleaning or repairing them as needed. A malfunctioning water pump can lead to coolant system issues. Replace or repair it through an overhaul to ensure proper functionality. Additionally, clean clogs in the exhaust manifold and silencer, as well as in the injectors. If the fuel injector pump is defective, undertake an overhaul and recalibration. Finally, inspect the cylinder block for scale formation or blockage in water passages and clean them to maintain efficient heat transfer.
Let's recap this session. The injection timing plays a crucial role, and if found incorrect, it should be reset for optimal performance. Clean clogs in the exhaust manifold and silencer as well as in the injectors. If the fuel injection pump is defective, undertake an overhaul and recalibration. Hope you have a clear understanding of this. Do this exercise with the help of your instructor. Thank you. and welcome to this session on performing troubleshooting practice with heavy vehicle for engine not starting. Let's start with this topic. On completion of this session, you will be able to identify the procedure to troubleshoot the excess oil consumption, analyze the high and low oil pressure in the engine.
Tools and materials required: trainee's toolkit, multimeter, a car in running condition, gloves, bunion cloth as required, emery sheet as required, cleaning solvent as required. Let's get started to perform troubleshooting for low power generation. Start the procedure by checking for external fuel leakage and any potential clogs in the fuel pipes, promptly addressing and rectifying any issues found. Examine the fuel filter and overflow valve, replacing them if clogged to maintain a consistent fuel supply. You have to regularly inspect the air cleaner, cleaning the filter if clogged to ensure proper air intake. Ensure the cylinder head is securely fastened, avoiding both looseness and over tightening so both can lead to problems. Check and adjust the tappet clearance if it falls outside the recommended specifications. Injection timing is critical for engine efficiency. Reset it if necessary. Inspect the exhaust manifold and silencer for any clogs, cleaning them to maintain proper exhaust flow. Address any defects in injectors through overhauling. A malfunctioning fuel pump can disrupt fuel supply, necessitating an overhaul for proper function. Similarly, a defective fuel injection pump should be overhauled and recalibrated to ensure precise fuel delivery. Finally, monitor compression pressure. If it is weak, an overhaul and adjustment are necessary to maintain the engine's optimal performance. Now, let's begin the troubleshooting for excess oil consumption. Begin by checking the oil level, ensuring it falls within the recommended range. If the level is high, remove the excess to prevent potential issues. Inspect for external oil leakage and address any identified leakages promptly. In the absence of leaks, assess the oil viscosity, and if it is below the specified range, replace it with the correct grade to maintain proper lubrication. Now, evaluate valve guide and ring clearances. If the valve guide clearance is high, replace the valve guides. If the ring clearances are excessive, replace the ring. Additionally, a thorough inspection of the piston, cylinder bore, or liner for wear is crucial. If wear is detected, an overhaul is necessary to restore these components to optimal condition, ensuring the engine's longevity and sustained efficiency. Let's now start addressing issues of low oil level, and quality is vital for the health of an engine. Start by checking the oil level and topping it up to the recommended mark. Next, assess the oil viscosity, and if it is below the specified range, replace it with the appropriate grade to ensure optimal lubrication. Examine the oil pressure gauge. If it is defective, replace it to obtain accurate readings. Inspect the oil strainer in the sump for clogs and clean it if it is necessary. Evaluate the oil pipes for cracks, blockages, or looseness. Replace cracked pipes, clean blocked ones, and tighten loose connections. Verify the functionality of the pressure relief valve assembly. If defective, undertake repairs to restore proper operation. Assess the oil pump. If found defective, an overhaul is necessary to maintain consistent oil circulation. Finally, check the crankshaft and camshaft bearings for wear, opting for an overhaul if needed to sustain the engine's efficiency and longevity. Let's delve into the procedure to troubleshoot high engine oil pressure. To ensure the health of the engine, start by examining the oil grade. If the oil is dirty, replace it with the recommended grade for optimal performance. Next, inspect the relief valve. If it is defective, clean and reuse it if possible. Otherwise, replace the valve to maintain proper oil flow. Additionally, assess the functionality of the oil pressure gauge. If it is found to be defective, replace the gauge to ensure accurate monitoring of oil pressure. Let us focus on troubleshooting on engine noise.
First, check the quality of the fuel. If the fuel quality is poor, switch to a higher quality fuel.
Examine the piston for excessive carbon deposits. If found, perform a carbon cleaning process to enhance efficiency. Assess engine bearings for wear. If owned, initiate a comprehensive overhaul of both the bearings and the entire engine. Inspect the fuel injection system for defects. If identified, overhaul the injector for continued use. Evaluate the crankshaft for excessive play. If present, consider an engine overhaul to address potential issue. Lastly, check for inadequate lubrication in the big end and main bearings. Rectifying any lubrication deficiencies to promote smoother operation and prevent engine damage.
Let's recap this session. First, check the quality of the fuel. If the fuel quality is poor, switch to high quality fuel. To ensure the health of the engine, start by examining the oil grade. If the oil is dirty, replace it with the recommended grade for optimal performance. Hope you have clear understanding of this. Do this exercise with the help of your instructor. Thank you. Hello and welcome to this session on perform identification of various sensors installed in the engine and its mounting. Let's start with this topic. On completion of the exercise, the trainees shall be able to, learners will be able to identify the location of ECU. You will be able to describe the functions of ECU.
Tools and materials required. Trainees toolkit, task lamp, latest vehicle, cotton waste, soap oil. Let us get familiar by understanding how to carry out identification of the electronic control unit. Let's get this started. The ECM is attached to the bottom of the control panel on the side of the passenger seat. The ECM is a precise unit made up of a microcomputer, an analog or digital converter, input or output unit, and other parts. Because it controls the fuel injector, IAC valve, fuel pump relay, and other important parts of the electronic control system, it is an important part of the system. It also has a fail-safe feature and a self-diagnosis system. There are many sensors in the electronic control system that pick up on the engine's start and the driver's conditions. The ECM then controls different devices based on the data from the sensors and there are also controlled devices. Here are the systems: fuel injection control system, idle speed control system, fuel pump control system, ignition control system, radiator fan control system. Choose the latest car to perform this operation. Put the car in parking mode and use a wooden choke on both the front and back wheel. Once after making sure that the car is idle, then we will start the procedure. Every car company sells a different ECU for each specified car model. Let us look at the well-known BMW X3 as an example. This vehicle has 28 iSports type in it. Different part numbers exist inside the same ECU, such as the make, model, year, and inside a specified mode. There may also be many alternatives available for each model. Let us look at an example to understand the ECU stickers. The ECU sticker shows the particular position of the ECU number. The arrow indicates the part number on sticker, such as 3780-POA-A51, 351-197338, 3782-POA-0A51 is an ECM for a hard accord. 1576-8288 is a term for a car-loaded truck. F7UF-12A650-AFB- is an ECM for a four-don. Identify the connection for diagnostics. This connector will be placed in the interior dashboard near the steering wheel of the car. Connect the OBD scan tool to the port. And now switch on the ignition key. The ECU will be indicated on the re-display of the scan tool diagnostic code for model, serial number, make, and defect diagnostic codes. If the ECU number is unknown, turn off the ignition with the key and remove the battery terminals. Unplug the ECU wire connection and remove the ECU mounting screws, and then remove and clean the ECU. Check the ECU sticker on the ECU and make a note of the identification number. If you are unable to identify the ECU, contact the manufacturer and give the vehicle's name, mode, and year of manufacture, facts about the production, and VIN to the manufacturers. Based on these details, they will help you in identifying the ECU number.
Let's recap this session on perform identification of various sensors installed in engine and its mounting. We learned that identify the connection for diagnostics. This connector will be placed in the interior dashboard near the steering wheel of the car. If the ECU number is unknown, turn off the engine and remove the battery terminals. Unplug the ECU wire connection and remove the ECU mounting screws. Then clean the ECU and note down the ECU number. Hope you have clear understanding of this. Do this exercise with the help of your instructor. Thank you.
Wherever you go today, you will hear some common questions, whether it is the young